Hello, algebra students. We're ready to start chapter 9. This first little note about the ACT doesn't mean a lot to you guys right now, but remember this for the future, that about 50% of the ACT, especially the science part, involves graphs. So maybe that'll make you perk up and listen a little bit as we talk about graphing quadratic functions. All right, quadratic functions are what we call nonlinear functions, which means they're not a line. Quadratic functions always start with x squared or have an x squared in them. So to be a quadratic function, you need an x squared, and of course this is our good old standard form, which helps us in factoring, and it will also help us in graphing. All right, the shape of a quadratic is called a parabola. And our golden arches over here are showing us parabolas. That's the shape that a quadratic function will make. If your x squared is positive, then your parabola is going to open upward. If your x squared is negative, like the golden arches here, your parabola will open downward. All right, the y-intercept is, of course, where it intercepts or catches or passes through or crosses the y-axis. And it just so happens in standard form, every time C is going to tell us where it crosses the y-axis. So instead of saying the point is 0y, you could almost say it's 0C, because the y is going to be the same as C. That'll become more obvious as we work through some problems. And next we need to talk about the axis of symmetry. Symmetry simply means balance. So the axis of symmetry is the vertical line passing through the parabola, going through its vertex, which we'll talk more about that in just a minute. And it splits the parabola into two equal sides. Okay, it's balanced or equal on each side. So here's a parabola, and I have free-handed here an axis of symmetry cutting this parabola. One's a positive parabola, one's a negative parabola, but we cut it into two equal parts. So this is an axis of symmetry. You could actually have a horizontal axis of symmetry too, but most of ours are going to be vertical, kind of like our thespian mask. I can't think what they're called. I think they have a name, but the happy sad mask has a nice axis of symmetry. Be sure and take note of this equation. This equation is what we're going to use to find our axis of symmetry. X, again, it's going to be a vertical line, so it'll be an x equals equation. And guess where this b comes from? It comes from standard form in ax squared plus bx plus c. So you'll find your a and plug it in, and find your b and plug it in, and don't forget to multiply times 2. This is our formula for finding the axis of symmetry. Now, I'm just throwing a lot at you right now. It's all going to become more clear as we work through some problems. Our next term is that term vertex. I told you we'd talk about that more. It is the minimum or the maximum point on a parabola. Remember, some of them open upward, so those have a minimum point, and some of them open downward. Those will have a maximum point. So the minimum is the vertex at the bottom, the lowest point on a parabola, and then a maximum is going to be the highest point on a parabola. And again, it depends on if it's an opening up or opening down parabola. To find the vertex, we're going to use the value you found for the axis of symmetry. When you found x, that's going to be your x coordinate of your vertex. Then, once you found your x, you're going to plug that number back into the original equation to find your y. Now we're going to work through several of these problems in just a moment, but let me just help you visualize. So let's say I have a parabola here. All right, the axis of symmetry is going to split it in half, and here is going to be the vertex. So the vertex is actually going to be on your axis of symmetry. And for this parabola, since it's opening downward, this is my maximum point. This is the maximum, and everything else is going to be below it. So this is your vertex on the axis of symmetry. Just making sure you are visualizing these terms. And same thing is true if my parabola, easy for me to say, right? If my parabola is opening up, here is my vertex on the axis of symmetry, and again, this one would have a minimum. All right, let's flip over to the next. All right, at the top of this page are the steps that you're going to need to graph. So number one is to put it in standard form. Put your equation in standard form, and then we need to find the axis of symmetry, and along with that we will find the vertex. So the axis of symmetry and the vertex. Now what was that formula? X equals negative b over 2a. That is the formula that will give us the axis of symmetry and also our x coordinate for our vertex. And then we'll take that value, plug it back into standard form to find the y. Then, after we've done step 2, we'll move on to step 3, which says find 2 points on each side of the graph. In other words, you have your starting point, but you need to know where 2 other points are so you can then give a rough sketch of your parabola. It's just like lines, you need 2 points to determine a line. You're going to need a total of 3 points to determine a parabola. So keep that in mind. Now let's work on some examples. So number 1, it's already in standard form. So that takes care of step number 1. A equals 1, B equals negative 1, and C equals negative 2. All right, so I'm ready first to find my axis of symmetry, which is negative b over 2a. So for this problem, it's going to be negative 1, if I can get my pen to catch, over 2 times 1. So negative makes positive, so x equals 1/2. All right, what is our vertex? Well, I know the x coordinate is going to be 1/2, and I need to find the y coordinate. So to find the y coordinate, we go back to our original equation, y equals x squared. We're going to plug in 1/2 squared minus x, which was 1/2, minus 2. And all of that's going to give us a y value of negative 2 1/4. So my vertex, to finish the vertex, is negative 2 1/4. So this is all running together. So our axis of symmetry is x equals 1/2, and our vertex is here. And now I need to state my domain and my range. Well, on all parabolas, your domain is going to be all real numbers. Your range is going to be y, such that y, and in this case, it's positive. Our x squared is positive, so it's going to open upward. So y is going to be greater than or equal to, and our lowest y value, negative 2 1/4. Let that soak in for just a minute. We'll put our domain and range brackets, those sets of numbers. So let's graph it, and maybe that'll help. Oh, and I need 2 other points. Remember how I needed 3 points. So I know I have the vertex. Let's go ahead and plot that. The vertex was 1/2, which is kind of tricky, and negative 2, 1, 2 1/4. So our vertex is about right there. So let's find two other points that hopefully are on the grid. So if I plug in 1 into my original equation, it's 1 squared minus 1 minus 2. So that's going to leave me with a negative 2. So there's the point 1, negative 2. Oh, and this is going in, there it is, 1, negative 2. And if I plug in negative 1, that's going to give me negative 1 squared minus a negative 1 minus 2, which is going to end up being 0. So negative 1, 0 is actually going to be on the x-axis. Boy, it'd be nice if I could figure out the number for the y-axis. Well, let's try 2, because it looks like 2 might land on 0 also. So 2 squared minus 2. Oh, minus 2. That's going to be 4 minus 4. It does equal 0, so I was right. So there's 3 points. Here's my vertex. There's that nice point that I accidentally found. And then there's 2 other points. So there's my parabola. Now let's go back and recap what we already know. Our axis of symmetry is at 1/2, passing through that point. Our vertex is 1/2, negative 2 1/4. So here's my axis of symmetry and my vertex. And let's talk about domain and range for a minute. We said all real numbers for our x values for the domain, because here it's going to start this way and it's going to keep getting wider and wider and wider, so it'll be all of our x values. And then for the range, we said y is anything greater than or equal to negative 2 1/4. So it's not ever going to go below negative 2 1/4. So any number greater, because our parabola is going to keep growing and going upward. I'm going to let you try 2 and 3 on your own. Flip on over to the next page. Here is a nice recap in our box of everything we talked about. Number 1 and number 2 here, again, is asking us to find the axis of symmetry, the vertex, and the y-intercept. So, all right, so the axis of symmetry, x equals negative b over 2a. So x equals negative 1 over 2 times 1. So x equals positive 1/2. So there's your axis of symmetry. I left it all here in red. Now to find the vertex, we know that x is going to be 1/2, and we need to find our y. So here it is, y equals, and in place of x, we're going to put in 1/2, x squared minus 1/2 minus 2. And we can punch all that into our calculator, and we find out that y equals a negative 2 1/4. Is this the exact same problem that I just worked? I think it is. Okay, so on the previous page, we did not really talk about the y-intercept when I worked this problem before. So guess what? The y-intercept is where x is 0. So y equals, if we make x 0, that's going to be 0 squared minus 0 minus 2. Guess what y equals? A negative 2. So our y-intercept is 0, negative 2. So I've color-coded here. The vertex is in blue, axis of symmetry is in red. And that's how you would find each of those 3 items. Okay, we're running out of time. Number 2 is number 2 on the previous page. So find the y-intercept if you didn't already find that when you graphed it. And the last thing we're going to do on this video is to look at graphs and to identify the axis of symmetry here is at positive 2. The y-intercept is at 0, 2. The vertex here is at 2, negative 2. And the domain is all real numbers, and the range is y, such that y is greater than or equal to negative 2. Try the next one. Pause the video here. I'll tell you the answers to the second one in just a moment. I hope you're able to find the axis of symmetry here is at 2. It intercepts the y-axis at 0, negative 4. The vertex is at 2, 4, which makes the domain all real numbers, and our range y less than or equal to 4, because our parabola opens downward. It has a maximum. Have a great day.